Let us make it more interesting. In this example, we have an expression which is 3x to the fourth minus 6x cubed, finally minus 72x squared, and question says factor completely. Very well. So take a look at your expression. Here you have x to the fourth. The degree of this expression is actually 4. Of course, it's a trinomial. Here you have 3 terms. 1, 2, 3, 3 addends, 3 terms. The degree is 4. So what should I do now? Take a look at your trinomial with degree 2 and leading coefficient 1. Our goal is to rewrite this expression so we can derive some information which gives us numbers b and c with leading coefficient 1. Okay, take a look at the first addend. It is 3 times x to the fourth. I'm looking at my last term that has the least degree or power, which is 2. So my job is actually to rewrite this x to the fourth into the form that I can actually see exponent 2. How? This is 3 times x to the second times x to the second. Am I allowed to do that? Of course, why not? This is x squared times x squared. The base are the same, x and x. Divide one base and add the exponents. 2 plus 2 is 4. How about this one? It is x cubed. Can you derive x squared from it? Of course, why not? First of all, remember that this is 6. 6 is 2 times 3. X cubed is x squared times x. Take a look at this. You have invisible exponent, which is 1. If you write one base, which is x, you need to add these two x and get 3 back. So you're allowed to break x cubed into x squared times x to the first power. As I mentioned before, we just erase exponent 1 for simplicity. We just write it as x. And finally, we have minus 72. 72 is actually 3 times 24. And here, since I want to see x squared in all of them, I'm going to copy down x squared here. Now, what is the common factor, and eventually, what is the greatest common factor in all of these addends? As you guessed correctly, 3x squared is going to be the greatest common factor between all of these addends. So what we're going to do, we're going to factor out 3x squared. We're going to write it outside parentheses. Well, if I factor out 3x squared, I left with x squared here. Hey, take a look at your trinomial. The leading coefficient is 1 minus. I'm factoring out 3x squared. I left with 2x minus 24. So some part of factorization is done, some part of it. We still have to deal with x squared minus 2x minus 24 by using the formula that we just learned, how to actually write this quadratic expression into the multiplication of 2 linear expressions. So step by step, one by one. What did we do? We actually factored out the greatest common factor from all of these addends. Next step is to try to factor out the quantity inside parentheses, which is actually the product of 2 other linear expressions. So note that, don't forget about this little term here. This is 3x squared, so you have to copy this down. It is part of this huge expression here. So copy 3x squared down. Here you have the product of 2 linear expressions. x plus missing box, x plus the missing box. Very well. Okay, you're looking for two numbers. Their product is -24 and their sum is -2. So let's write them down here. The product is equal to -24 and their sum is equal to -2. Let us do our best. So the product is negative. It means that one of those numbers is a negative number. You have 24. 24 is 1 times 24 or 24 times 1. Remember that one of them is negative, so -1 times 24 or 1 times -24. You also have 2 times 12. So -2 times 12 or 2 times -12. What else do we have? 3 and 8. 3 times -8 and -3 times 8. What else do we have? 4 and 6. Yes, of course. 4 and -6. -4 and 6. Okay. Pretty much it. Yes, we don't have any other, factorization of number 24. So let us try to see which one gives me the sum equals to -2. So 24 minus 1, not much. This is 23. So it's not a good option for me. I'm looking for two numbers that their sum is actually -2, -2. So 1 minus 24, it gives me -23. Nope, not a good option. -2 plus 12, which is 10. Of course, it's not -2, so not a good option. 2 minus 12 gives me -10. Again, I'm looking for -2. 3 minus 8 gives me -5. Nope, it's not -2. So -3 plus 8, +5. Not a good option. What about 6 and -2? Hey, 6, -6, 4 plus -6 is -2. So the answer is actually here. If you add these two, you get -4 plus 6, which is 2. Again, this is not a good option because it gives me the sum equals to positive number. I'm looking for negative number. So the best option is 4 and -6. 4 times -6, -24. 4 plus -6 is -2. So the complete factorization gives me 4 plus 4 minus 6. Remember, you can always check your work. First, use FOIL method or distribution. Multiply these two linear expressions, then distribute 3x squared. Well, before moving on to the second case where a is not equal to 1, I'd like to review one example. So this is our case 2. Let me erase this board for you. So we are in the case that a is not equal to 1. It's just another number. And this is actually our second case, case 2. So if we're going over this method, let us recall what we learned before. Remember that. Recall. If we have an expression similar to, let me write down the example from the book for you. 2x times x minus 4 plus 3 times x minus 4. And I ask you to factor this completely. Remember that you say that, hey, the common factor between these two addends, the common factor between these two additions is actually a linear expression, which is x minus 4. So I can take out x minus 4, write it in front of parentheses, x minus 4, write it in front of. If I take out x minus 4 from the first addend, I left with 2x plus. If I take out x minus 4 from the second addend, I left with 3. And this is the complete factorization of this expression. Now, think about it this way. Here you have a x squared plus bx plus c, and your job is to factor this expression completely. How would you do that? If you can break down the middle term into two linear terms and write it having 4 addends, you can actually factor out something from the first 2 addends, factor out something else from the second 2 addends, and actually factor out the common expression between them. Take a look at this example. I'm going to solve an example for you and write the instruction up here. Factor completely. Very well. In this example, we have 2x squared minus 5x minus 12. Guys, note that a is 2, the leading coefficient is 2, it is not equal to 1. So you cannot just directly write, hey, this is x plus a number, x plus a number. If you multiply x by x, you don't get 2x squared back. So we have to come up with another method. What I'm going to do, I'm going to break down the minus 5x to the sum of 2 other linear expressions. How do I do that? So break negative 5x into the sum of 2 other linear expressions. Copy down the first term, the last term, 2x squared plus and minus 12. So what are these two terms? So to find these two terms, you need a number times x plus another number times x. So let us add x's here, so you know that these are just terms, linear terms. You're looking for these two numbers. What are these two numbers? Note that I'm trying to get 4 terms. I had 3 terms, I had 3 addends. Now I'm trying to create 4 addends. Very well. The product of these two numbers is equal to 2 times negative 12, and their sum is equal to minus 5. So the product of these two numbers is equal to 2 times negative 12, a times c, ac, 2 times negative 12, and their sum is equal to b, which is negative 1. They're looking for 2 numbers. Their sum is equal to negative 24, and their addition, their sum is negative 5. What are those 2 numbers? Let's try our best. Here you have negative 1 times 24, or you have 1 times negative 24. You also have negative 2 times 12, or 2 times negative 12, or you have 3 times 8, negative 3 times 8, 3 times negative 8. So my suggestion for you is when you start writing this factorization of number negative 24, try to add those to see if you get to negative 5 faster or not. So negative 1 plus 24 is 23. not a good option. 1 minus 24, negative 23, not a good option. Negative 2 plus 12 is 10, no, I need negative 5. 2 and negative 12, 2 minus 12 is negative 10, no. Negative 3 plus 8, very well, I get 5, I'm getting closer. And 3 minus 8, negative 5. This is the option that I'm looking for. So I created 2 linear terms. What are the numbers? 3 and negative 8. 3 times negative 8. Again, it doesn't matter if you write negative 3, 8 or 3, negative 8. You get the same exact factorization. So I have minus 8x plus 3x. The order is not important. You can write 3x first, negative 8x second, or you can just write it as negative 8x plus 3x. So we break down b into the sum of two expressions. The first expression times x plus the second expression, which is the second number times x. Here you have ax squared plus c. This is called AC method. AC method. So the multiplication of these two numbers must be equal to a times c. That's why we call it AC method. So the first box times the second box is AC. Remember that? AC in our case was 2 times negative 12, negative 24, and their sum is equal to the sum 3 plus negative 8 is negative. So what's next? You have 4 terms. When you have 4 terms, you try to group them and find the greatest common factor in each group. In this group, the greatest common factor is 2x. So you left with x minus 4 plus, remember that, the operation in between addition. Between these two terms, the greatest common factor is 3. So x minus 4. Well, you have 2 addends. You're getting closer and closer. You have 2 addends. Between these 2 addends, x minus 4 is the greatest common factor. So you can factor out x minus 4. You left with parentheses 2x plus 3. Factor completely. Another example for you. We're going to use AC method again to factor something completely. Example says, factor completely. Factor what completely? This is the expression that you have. You have 12a squared minus 19ab plus 5b squared. Very well. Okay. We're applying AC method, and this is very similar to what we have here. Okay. So our goal is to break down the middle term into the sum of 2 other terms. A number times AB, another number times AB. So let us write down these. You're looking for those missing numbers. And here you have plus, you copy down the first term, you copy down the last term. Well, what are these 2 numbers? We'll have to find them. The multiplication of these 2 numbers is equal to A times C. What is A? 12. What is C? It is 5, which is 60. And their sum is equal to minus 19. Their sum is minus 19. Okay. You might say, hey, we already have 12 times 5, but 12 plus 5 is equal to 17. So even though if you consider negative 12 and negative 5, it's going to be negative 17, not negative 19. So this is not a good option. Let us investigate to see what are those two numbers. Well, let us start. The product is 60. It can be 1 times 60. Note that here we're going to get a negative number, so negative 1, negative 60. If you add them, you get negative 61. Not a good option. I'm looking for negative 19. What else? Negative 2 times negative 30. Well, the multiplication gives me positive 60, but how about if I add them together? Negative 2 minus 30 gives me negative 32. It's not negative 19. So not a good option, not a good option. What else do we have? You might say, hey, how about 3 times 20? So negative 3 times negative 20. Okay, of course the multiplication is equal to 60, but how about the sum? Negative 3 minus 20, it gives me negative 23. Not a good option. Not a good option. What else do we have? What else? How about 4 times 15? Negative 4 times negative 15. How about these two? Am I getting closer? Negative 4 times negative 15 is actually 60, positive 60. If I add them together, I have negative 4 minus 15, which is negative 19. Yes, we found negative 19. So the missing numbers are negative 4 and negative 15. So let us get back here. Negative 4 minus 15. So I have 4 addends. I'm going to group them 2 by 2, try to find the greatest common factor, and move on to the next step. Between these two, the greatest common factor is actually 4a. So I get 3a minus b. Between these two, the greatest common factor, here you might say it is 5b. Okay, if I write it as 5b, I get, here I have negative 3a plus b. I can write them as b minus 3a. Okay, take a look at this. What do you have? What's the difference between these two terms? You have 3a minus b, b minus 3a. What if you just factor out minus 5b? Let's take a look at this. If I factor out minus, let me use a different color so you see what I factored out here. What if I factor out negative 5b? Take a look at this. Here I get, if I factor out negative 5, or if I divide negative 15 by negative 5, I get positive 3 back. Negative 15 divided by negative 5 is positive 3. And I'm factoring out b as well. So I left with 3a. Now 5 divided by minus 5 gives me negative 1. Negative 1 what? Do I have the same common factor? Of course. Between these two, now we can factor out 3a minus b. 3a minus b. What's left? If I factor out 3a minus b from the first addend, I left with 4a minus. If I factor out 3a minus b from the second addend, again, 5b back. Here I have the complete factorization. You can always check your work by multiplying these back and get to the exact same original given expression in the exam.